All right, we are on part 3 for this factoring quadratics series. So in this part, we're going to focus on when a is not equal to 1. In the first two parts, if you remember, we only considered a equals 1, and then we considered different signs for b and c. Now we're going to open up the options even more and let a be something that's not equal to 1. So like a 2, maybe, or a 3, maybe, or a 10, anything else that's not 1. Okay? There's lots of ways people teach factoring. I'm going to present the way that most teachers teach it nowadays from just experience from me helping students. And then I'll show you the way that I think about it, how I learned it. I actually learned it from my mom teaching me how to factor before I even learned it in the school system. She wanted me to get ahead. Okay, by the way, before we go on to factoring these quadratics, let's review a few other things first to help us with factoring these quadratics. So let's review two examples of factoring the greatest common factor, GCF, okay? If we have, for example, 3xy plus 3x, the common factor, the greatest common factor is 3x. There's a 3 in both terms. There's an x in both terms. So we can factor that out of both terms. So it becomes 3x times in parentheses. What's left? If we take out a 3x from the first term, we're left with y. If we take out 3x from the second term, we're left with the 1. So in the parentheses, it's y plus 1. Okay, and notice if we distribute it back, you get 3xy plus 3x. Okay. Another example, 4xy squared plus x squared y. Do we have any common factors between the two terms here? And x is common to both. Yeah, you can take out x from this, and you can take out x from this. You can't take out x squared because there's only one power over here. So the greatest common factor for in terms of the x, just x terms, I should say, is x. Similarly, we can take out a y also because there's a y over here in the second term. There's two y terms over here. It's y squared, right? So you can think of it as two y terms. So you can take out one of them. Yeah? So the GCF is xy. And then what's left inside the parentheses will be 4y plus x. That's remaining. So notice if you distribute it back, you get the left-hand side again. Okay? So we have to remember how to factor GCFs. Okay? And then a little more, a further step from that is what they call factoring by grouping, okay? We'll go through two examples as well. So in this first example, x squared plus 2x plus xy plus 2y, let's focus on the first two terms over here. We're going to group them into pairs. So this first pair over here and this last pair over here, the second pair over here. In this first pair, what's the GCF? It's x, okay? And then it factors to x times x plus 2. In this second pair over here, the second group, what's the GCF? It's y. So we can factor out the y, and in the parentheses, it's x plus 2. Okay? This is just to show that we can factor once more. A lot of students struggle to see this at first. So let's do a little substitution, okay? Let's define this new variable z to be x plus 2, or z if you're, was that, I'm not, I'm American, so I say z. Okay, by the way, let's let z be x plus 2. Okay, whoops. Okay, so wherever there's an x plus 2, we're going to substitute with a z. Okay, so notice when we do that, it's much easier to see that z in these two terms now is the GCF. So we can factor that out. So it becomes z times x plus y. Yeah, and then we can back substitute z is x plus 2. So let's put that back in, right? So instead of z, let's write back x plus 2. And then this x plus y remains. So notice the whole point of me doing this is this x plus 2 is the GCF for these two terms here. I just represented it with a z to help you see that. But this is important when we go into factoring these quadratics with a not equal to 1. You have to see that this x plus 2 is the GCF, so we can factor that out directly. So let's do another example. A cubed minus a squared minus AA plus 8. So in the first two terms, let's put that as one group. What's the GCF there? It's a squared, so it becomes a squared times a minus 1. And the second group over here, the second pair, what's the GCF? we can factor our 8, but why don't we do a negative 8 instead? Okay, so it becomes a minus 1 inside the parentheses. The reason I want to do negative 8 as the GCS is because, look, a minus 1. A minus 1 is here as well. This is the GCF now of these two terms. So let's factor that out. Let's pull it out. And what's left on the inside? It's a squared minus 8. Okay, once again, we have to be able to do this in order to succeed in these factoring problems now. Okay, so let's go through the procedure to factor when a is not equal to 1. It's slightly different than what we've been doing in parts 1 and 2. In parts 1 and 2, we just found two numbers that multiply to c and add to b. It was actually a special case of what we're going to do now. Okay, we actually want two numbers that multiply to a times c. We have to take this a into consideration now. We want two numbers that multiply to a times c, and they still add to just b. Okay, so that's the only difference. You need them to multiply to a times c. So for example, in this quadratic, 3x squared plus 10x plus 8. So you want two numbers that multiply to 8 times 3, which is 24. You want the two numbers to multiply to 24, and they add to 10. The reason I said what we did in parts 1 and 2 is a special case is because when a is 1, 1 times c is just c. So you want the two numbers to multiply to c. So that's why it's a special case. Okay? And this is the example here. X squared plus 5x plus 6. In the previous parts, we just said we want two numbers that multiply to 6 and add to 5. If we do this more general procedure, we want two numbers that multiply to 6 times 1, which is 6 still. And then we want them to add to 5. Okay, so once again, what we did previously is just a special case of this more general procedure we're going to do now. All right, example 1. 3x squared plus 10x plus 8. So we want two numbers that multiply to 3 times 8, which is 24, and they add to 10. Okay? And we could use the tips and tricks, I can't speak right now, that we learned in parts 1 and 2. Okay? Because they must multiply to positive 24. 8 times 3 is positive 24. The two numbers must be both positive or both negative, remember? And because they must sum up to a positive, that must be both positive then. Okay? Remember that concept from part 1 and 2? All right, so when we think of the two numbers, we hopefully thought of 6 and 4. 6 times 4 is 24, and 6 plus 4 is 10, okay? So this is what we do here. Again, what we did previously was a special case, but this is actually the more general case, okay? So the 6 and 4 that we found, we're going to break up this middle term, this 10x term, into 6x and 4x, okay? So it becomes 3x squared plus 6x plus 4x plus 8. Notice that if we combine these two, we get back to 10x originally, yeah? That's why we found the two numbers. We want to break this middle one up into 6x and 4x, the two numbers, okay? Now we're going to do the factor by grouping that we reviewed. We're going to treat these first two terms as one group, these last two terms as another group. What's the GCF of the first two terms here? It's 3x. So 3x times x plus 2. How about the GCF for these two? It's 4. So it's 4 times x plus 2. Oh, look. This is why I went over those review examples. X plus 2 is the GCF here of these two terms. So we factor that out, and what remains, this 3x and this plus 4. Okay, that's how we factor this one. Okay, the key, once again, is the key points are you need the two numbers to multiply to 24, not to 8 here. Okay, and then you use those two numbers to break up this middle term over here. And then you factor it by grouping and all that. Okay, what happens if I put the 4x here and the 6x here? Since I wrote 6 and 4, I put 6x here and 4x here. But what if I swap the order? Okay, so what if I wrote it as 3x squared plus 4x plus 6x plus 8? So notice, I didn't change anything still from the original. Yeah, 4x plus 6x is still 10x, but the groups changed. The first group, the first two terms here, is different now. And the second group is different as well. Does it change the answer? It doesn't, because we still factor by grouping. Look, the first two terms was the GCF. It's just x. So then the inside's 3x plus 4. How about the second two terms? What's the GCF? It's 2. And then when we factor out 2, we get 3x plus 4 on the inside as well. And then 3x plus 4 is the GCF, so we factor that out, and we're left with x plus 2 on the inside here, which is the exact same thing as this, right? Just the order is swapped, but that's fine. Multiplication is commutative, right? So the takeaway is the order doesn't matter for how you write it. Okay? All right, let's do another example. Example 2, 2x squared plus 3x minus 9. So in this case, we want two numbers that multiply to -9 times 2, which is -18, and they add to 3. Okay? And then remember, we can use the tips and tricks from the first two parts. Since the product is negative, but sorry, this one I should be honing over. Product is negative, so one number must be positive, one number must be negative. The sum is positive, so the positive number must be bigger in magnitude. Remember those tips? So that can help us think of the numbers a little quicker, hopefully. And once you figure it out, you'll find that it's 6 and -3. Okay, 6 times -3 is -18. 6 plus -3, or 6 minus 3 is 3. Okay, so once again, we're going to use these two numbers to break up this 3x. Okay, 2x squared plus 6x minus 3x minus 9. Notice this 6x minus 3x simplifies to 3x, the original. I did not change anything. This is just a hack to help you factor. Okay, now let's factor by grouping the first two terms. What's the GCF? 2x. What's left? X plus 3. Next two terms. What's the GCF? It could be 3, but let's do a -3. So it becomes x plus 3 on the inside here. By the way, I didn't say this. It's a good sign when these match. That means you probably did it correctly. Okay? And that's why, from experience, you can tell that you want to factor out a -3 from these two terms over here, purposefully to get this x plus 3. If you factor out a +3, you would get -x minus 3, which doesn't match. So you have to factor out an additional -1. Okay? And then the final factor form is x plus 3, 2x minus 3, because this x plus 3 is the GCF. Okay? Two more examples. Example 3, y equals 5x squared minus 18x plus 9. So we need two numbers that multiply to +45, and they add to -18. Okay, so the two numbers must be negative. All right? So what are the two numbers? If we think about it, it's -15 and -3. -15 and -3. So we're going to use these to break this one up as -15x minus 3x. Let's factor by grouping the first two terms, which is GCF, 5x. Second two terms is the GCF, -3. And notice these match after we factored, then that's good. Now let's factor that out. That's the GCF. So x minus 3 times 5x minus 3. Okay, I'm going through them a little quicker now. Example 4, this one's a little different. We have y equals 16x squared plus 60x minus 100. You could factor it like we did. So we need two numbers that multiply to -1600 and they add to +16. Do you want to start finding factors that multiply to -1600? I kind of don't want to. It's too big. So instead, we noticed that we could actually factor out a GCF from these three terms, like 4. Okay, that is the GCF, actually. We could factor out like a 2, but that's not a GCF. The GCF would be 4. Okay, so the reason why we want to spot these is precisely to make the numbers a little nicer later. Okay, so let's factor that out. So 4 times 4x squared plus 15x minus 25. Okay, now the numbers aren't as bad because now we need two numbers that multiply to -25 times 4. That's -100. And they add to 15. Much nicer than the -1600, right? So what are the two numbers? That's 20 and -5. Okay, I can't help you there. You have to figure that out for yourself. So let's break this 15 up with this 20 and -5 right there. First two terms, let's factor the GCF. That's 4x. What remains is x plus 5. Second two terms, let's factor out a -5 such that what remains inside is x plus 5. It's matching, very good. So let's factor the x plus 5 out. So it becomes the final answer 4. Don't forget the 4 that we factored out in the beginning. 4 times x plus 5 times 4x minus 5. Okay, this is a typical procedure that most of my students learn. Some of them learn like this box method and all of that, but it's pretty much all the stuff I'm explaining here. Okay, let me go through an alternative way. And this is how I think of these factoring problems. You can totally skip this if you're not interested. I want to just focus on the typical method, if it's the one that your teacher taught you and expects you to know. If you're curious, then please continue watching. Or if your teacher allows you to not follow these methods and you want a different way, then let's continue. Okay, let's redo the same four examples and I'll explain it in a different way. Okay, so we have 3x squared plus 10x plus 8. Okay, remember the sign things that I went over in part 1 and 2, the format, if it's like plus plus or plus minus or minus minus, remember that? If we can apply that here. Since the two numbers must multiply to a positive number and they add to a positive number, it must be both plus over here. There's no way around it, okay? So in general, let's notate it with some letters. Px plus q, rx plus s, okay? If we expand this out, if we FOIL it, we get PR times x squared plus PS plus QR times x plus QS, okay? So this is the general form. This is the general factor form. We'll have to find these P, Q, and R and S, okay? All right, so PR needs to multiply to positive 3, okay? And we need Q and S to multiply to 8, okay? We pay attention to that, all right? And now let's think for the P and R. What two numbers multiply to 3? 3 is prime, so it has to be 1 and 3. There's no other choice, yeah? So we can already know the factor form is in the form of 3x plus something, x plus something, okay? Hopefully you're following so far. Now let's worry about this QS. They need to multiply to 8, okay? This is the Q and this is the S over here, yeah? So what two numbers multiply to 8? It could be 1 and 8 or 2 and 4, okay? So either it's 1, 8 or 8, 1 or 2, 4 or 4, 2. Hopefully you followed my cursor, okay? Those are the possibilities. Okay, so let's go through all of them. So if I put 1 and 8, if I expand everything out, I would get 3x squared plus 25x plus 8. Doesn't match this guy clearly, right? Let's try the next candidate, 8 and 1. Notice the position matters here, okay? You would get an expanded form, 3x squared plus 11x plus 8. Still doesn't match that, okay? So it's not these two choices. So let's try the 2 and 4. 2 times 4 is 8, right? That's the only other possibility. So let's put 2 here and 4 here. You'll get 3x squared plus 14x plus 8 if we expand it out. Still not matching, so let's swap the 2 into 4. So 4 goes here, 2 goes here. If you expand it out, it's 3x squared plus 10x plus 8. Okay, so the answer is 3x plus 4, x plus 2, which matches what we did the other way. Okay, so I will say that this method is more puzzle-like, if you like puzzles, but it could also be seen as more guess and check. Okay, notice that I tried every single candidate, and the last one was the correct one. There's only one correct one, as expected, and it happened to be the last one. So why do I personally do it this way? Well, it can be quicker than the other way, especially if this first term, this A, is prime. Like in this case, 3 is prime. So it limits your possibilities a lot, okay? The other reason why it's quicker is if you're good with mental math, you can do these additions quickly in your head, okay? Of course, if your teacher requires you to do it the other way, please, by all means, well, please do that way. But this is an alternative way. If you're stuck with that way, or if you don't like that way, you can think of it in this way. If you like to do kind of like puzzles and guess and check type of thing. And of course, with more experience, you'll make more educated guesses as to which of the ones probably are not right. For example, we want a sum of 10x, yeah? In this case, look, it'll be 3x times 8, which would be this 24x over here. And that's way off from 10x, way too big. So from experience, after you actually try and struggle through them, you'll notice that this is probably not it because the sum will be too big. Okay. Things like that you just get from experience. Okay. Example two, let's do another one. This alternative way, 2x squared plus 3x minus 9. Okay. So 2 is prime, which is very nice because we know that it must be 2x plus something, x minus something, or 2x minus something, x plus something. Okay. How do I know that these signs are like that? Well, we know that the two numbers must multiply to a negative number. So one is positive, one is negative. Yeah. So that's why one's positive, one's negative. But it could be like negative, positive as well. So we got to keep our options open. Okay. What are the factors for 9? It's 1 or 9 or 3 and 3. Okay. So I listed all the possibilities again. Okay. And remember I was saying from experience, you can get that sums are too big or too small, stuff like that. I'm trying to show that more over here and some other tips and tricks, okay? So first possibility, 2x plus 1, x minus 9, okay? Well, if we expand that, we'll notice we have a minus 18x plus x, which is minus 17x, way off from this plus 3x, yeah? Okay, and then notice if I just flip the signs, you would get positive 17x if you expand it out. Notice that. This is important. I think I went over this in parts 1 and 2 for the simpler case. This is just the opposite sign. So in the future, if you never noticed this, you can eliminate just flipping the sign if you did one of them already and the sum is way off. The sum is still way off. It's just positive version. Okay. Next, we could flip the position of the numbers as well. So 2x plus 9, x minus 1. If we do that, the sum is, see, this is why we have to do the mental math quickly on ahead. It's 9 minus 2. So right there, right? Minus 2x plus 9x. That's 9 minus 2. It's just 7x. It's still off. And don't bother flipping the signs, but I just showed it here. If you expand out, the sum is negative 7x as expected. Okay. Now what about over here? 2x plus 3, x minus 3. This is the last choice because we eliminate all 1 to 9 candidates over here. Yeah. How about 3 and 3 now? So we're left with that. So if we expand it out, the sum is negative 3x. We want positive 3x, so it's just a sign difference. Let's flip the signs. Okay, so therefore, factor form is 2x minus 3, x plus 3. Okay, again, you can see that I'm showing that there's lots of possibilities here. So if you don't want to do this and you want a kind of more systematic way, please do the other way. But I'm arguing that from once you get the hang of factoring, this is typically faster, especially when these numbers are prime over here. Okay. Okay, here's me explaining more of the thought process. Remember, I was saying that if you put the 9 here, you would get an 18, yeah? 9 times 2 is 18. That's way off from this plus 3 that we want. So you want the number over here that's being multiplied by 2 to be smaller as a result. Okay? And then here's the sign flip I was saying. So don't even try it once you figure out that this one is not right. Okay? So, as I was saying over here, you probably don't want the 9 here because it'll become an 18 when you multiply it by the 2. Or there'll be an 18, I should say, which is way awesome. Maybe let's try this 1 over here. It doesn't work though. So let's move to the 3, 3 option, and then it worked in the end. Okay. And as I said, it just comes from experience practicing. You got to figure this out for yourself. I can only give so many tips and tricks. You got to figure them out for yourself. Even I don't remember all the tips and tricks off the top of my head. Okay. Example 3, 5x squared minus 18x plus 9. Okay. We see a minus plus, so then the two numbers must be negative. Yeah. The two numbers must multiply to a positive number and they add to a negative. So they have to be both negative. Okay. 5 is prime, makes it nice. So we eliminate a lot of choices actually. It'll just be 5x minus something, x minus something. So what are the factors for 9? It's once again 1 to 9 or 3 and 3. Okay. So let's try the 1 and 9 first. And remember from the other one, let's try not to make this sum too big. So let's not put the 9 there. Okay, let's put the 9 here instead. Because if I put the 9 here, you have the 9 times 5, which is 45, which looks too big compared to negative 18. Yeah. So let's probably not do that. So instead, let's put the 9 here and the 1 here. If we expand it out, let's do the math in our head. It'll be minus 5 minus 9. Minus 14x would be the middle term, this middle term, which is not matching negative 18x. Okay. This bullet point, I'm just saying, let's not put the 9 there as I explained already. Okay, so let's try the 3 and 3. 5x minus 3x minus 3. Let's do the addition in our head and multiplication. Minus 15 minus 3. That's negative 18x. This should be negative over here. Okay, which matches there. So we know that's 5x minus 3, x minus 3. Okay, so hopefully you kind of see now, once you get experience, this method is actually quicker because you don't have to do all the factoring by grouping that we did in the other method. Okay. And of course, I just want to emphasize once more, if your teacher requires you to do it the other way, please do it the other way. If you're past that point and you're still stuck with factoring, you can possibly consider this method. Okay. And last example, example 4, doing it the other way, you still want to factor out the GCF first, okay? Which is 4. I want to make these numbers smaller for you, always, okay, if possible. Okay, so here is an example where 4 is not prime, so there's actually more possibilities. And then the sign is the plus, the sign is the minus, so one term is going to be negative, one term is going to be positive. So there's lots of options in the case. That's what I'm writing here. So the 4, what makes 4 is 1 and 4 or 2 or 2, right? So it could be 2x plus something, 2x minus something, or it could be 2x minus something, 2x plus something. Or it could be 4x plus something, x minus something, or it could be 4x minus something, x plus something. Lots of possibilities here. Okay, what about 25? What makes 25? It's 1 and 25 or 5 and 5, so it's not too bad, okay? And this is, again, from experience, let's not try 1 and 25 because if we put 25 into one of these, you'll get a 50, yeah? So maybe let's not do that, okay? Or maybe we do. Actually, yeah, I'm getting confused. 60, 50, that might be close, but it's 15. Remember, we factored this 4 out. If we put a 25 in, we'll get a 50, as I was saying, but we want it close to 15, so probably not that, okay? So from our intuition, let's try 5 and 5 first, okay? Now, which one do we want to pick? 50% chance. Let's try this one first over here, okay? Like 2x plus 5, 2x minus 5, okay? This won't work because the sum, if we expand this out, would be 0x. Okay. This is the difference of two squares, which I'll cover in part 4. Okay. So that's not it. So let's try. Remember, if we just swap the signs, it won't change anything. Sorry, it will change just the sign of the sum, but it's 0. If you change the sign of 0, it's still 0. Okay. Let's do try 2. Let's move to this one instead and do the 5 and 5. Okay. The 4x plus 5, x minus 5. Let's figure out the sum portion. Will be minus 20 plus 5. Yeah, which is minus 15x. We want plus 15. So what do we do when we have the opposite sign? You flip these two signs. So it becomes x plus 5, 4x minus 5. And that's the answer. Okay. Hopefully you see that this took 3 tries. Not too bad. Versus if you do the factor by grouping, you'll have a few more steps to show. So up to you as to which method you want to think about. I personally choose to do this way because this is how I learned it. And honestly, in my opinion, it's most of the time quicker than doing it the other way. All right. Hopefully this was helpful. If you needed a refresher or you wanted an alternative way to think about factoring. There's one more part in this series. As of now, I'm talking about the special factoring cases, like difference of two squares that I hinted over here and things like that. Hopefully I'll see you in that video as well. Bye.